Hi you guys, today we are moving on to Chapter 8 or Unit 8, and we're going to be talking about factoring. Today is all just kind of an intro to factoring, so we're going to be using the distributive property to kind of undo some of our multiplication that we've been doing recently. So first I just want to do a refresher of our multiplying. So we've got 5x times x squared minus 3x plus 9. So this 5x term is going to get distributed to our three terms on the inside of our parentheses. So when we do that, we get 5x cubed minus 15x squared plus 45x. And you'll notice now each term that we've gotten in our new polynomial is factorable by 5. They all have the common term of 5, and they all have an x component to them as well, so that'll help us later on. Then the next piece that I want you to do is that 2ab times that polynomial of 3a squared b cubed plus 7a minus 8b minus 5. So we're going to distribute this 2a to all four of these terms. So we'll now get 2 times 3, which is 6. A times a squared, which is our a cubed. B times b cubed, which is the b to the 4. So that's that first term. Then we've got 2 times 7, which is the 14. And then a times a, which is a squared. And don't forget about the b. Then we're going to subtract 16a b squared minus 10ab. Okay, so today we're going to be talking about how do we do the reverse of what we just did. So we multiplied here, but how do we undo that multiplication? So our main vocab word for today is the greatest common factor. So that's the highest number that divides into two or more numbers or terms. So we're talking about terms here, not just numbers anymore. And your greatest common factor is never going to be negative. It'll always be a positive, okay? So now we're going to do some example problems together. So the first example is 6a cubed b to the 4th plus 14a squared b minus 16ab squared minus 10ab. Okay, so let's just look at all of our plain coefficients first. So we've got 6, 14, negative 16, and negative 10. So I'm just going to write the numbers. I'm not going to worry about their signs because, again, our greatest common factor is not going to be a negative number. So we've got 6, 14, 16, and 10. If we look at all of those numbers, what is the greatest common factor of that? What are they all divisible by? Well, they're all divisible by 2. Okay, and then we've got our a terms. So our a's, we have the a to the third, a to the second, normal a, and another normal a. So when we list all of those out, because there's one of those, an a component in each term, we need to ask ourselves, okay, what is the greatest common factor of those pieces? Well, they all have one a, so that part can be pulled out as well. And then last we've got our b's, so b to the 4th, b, b squared, and another b. So if we look at all of those pieces, what is the greatest common factor? What are they all divisible by? Well, they're all divisible by 1b. Okay, so now that is the component we're going to pull out onto the outside. So we're going to have 2ab on front, and then we'll have our parentheses. So now we need to divide each term. So this is kind of related back to our long division. When we look at this first term here, we've got that 6a cubed b to the 4th. Well, we just divided it by 2ab. So 6 divided by 2 gets us the 3. A cubed divided by a gets us a squared. And b to the 4th divided by b gets us b cubed. So that's the first term, and we do the same thing with the next. So 14 divided by 2 is 7. A squared divided by a is a. B divided by b is just 1, so there's nothing else to write there. And then we've got minus 16 divided by 2, which is 8. A divided by a, those cancel out. B squared divided by b is b. And then last, our negative 10ab. Well, we pulled both the a and the b component out, so we just need to worry about the negative 10 divided by 2, which will get us negative 5. Close your parentheses. This is your final answer for our example problem 1. We're going to do the same thing with our second problem here. Now we just need to be very cautious because each term has a plain number, so we do need to determine what those are divisible by. So 2, 4, and 6, what are they all divisible by? What's their greatest common factor? Well, that's 2. But we also need to be very careful. We have an x squared and x, but our last term does not have an x component. So for this example, we will not be able to pull a variable factor out. We only can pull out the 2. So we've got 2, open parentheses, 2x squared. Well, when we divide by 2, that's just x squared. Plus 4x squared, divide that by 2, so we've got 2x. And then our 6 divided by 2 is just 3. So this is our factored answer for number 2. Okay, moving on to number 3, we're going to do the same things that we've been doing for 1 and 2. So we're going to look at those plain numbers first. We've got 3 and 18. Are they both divisible by a common factor? Well, they are. They're both divisible by 3. Then we need to look at our variables. Do both terms have an x component? Well, they sure do. One's x squared and one's x. So the greatest common factor out of those two is just going to be 1x. And then we look at our y's. Here we have a y in our second term, but we don't in our first. So we're not going to be able to factor a y component out. So we can factor out our 3x. Open your parentheses, 3x squared divided by 3x. The only thing that's remaining there is an x. Plus 18xy divided by 3x. That's going to leave us with 6y. So this is our factored answer for number 3. All right, moving on to number 4. This one looks a little bit more difficult. We've got 8, 12, 4, and 28. What are those all divisible by? What are the greatest common factor there? Well, it's 4. Then we need to look at our variables. We've got x cubed, x squared, and x squared. So they all have an x component. So we're going to be able to determine our greatest common factor there. So we've got cubed, squared, and squared. So the greatest common term out of those is just going to be our x squared. They're all divisible by x squared. So before we just had an x term, now we can do it squared if that is the greatest common one. And then last we've got our y's. We've got y squared, and y. So they all have a y component. So we're going to be able to factor part of that out as well. The greatest common factor there is just the normal plain y. So when we factor out, we know we're going to have a 4x squared y in front. Open your parentheses, and then we need to do our dividing. So 8 divided by 4 is going to leave me with 2. X cubed divided by x squared is going to leave me with x. Y divided by y is just going to cancel out, so my first term is now divided. And then I'm going to add my second term, so 12x squared, y squared divided by my factored out piece. So 12 divided by 4, that's 3. X squared divided by x squared, those cancel. Y squared divided by y is y. Same thing for the next term. We've got 4 divided by 4, that's 1, which is just going to be implied. I don't need to have that written down. X cubed divided by x squared is going to leave me with an x, and then y squared divided by y leaves me with a y. Our last term, 28 divided by 4, is 7. X squared divided by x squared, those cancel. Y divided by y, those cancel. So this is my final factored answer. Once you've completed these notes, please show them to your substitute for today, and you will pick up your practice sheet. It is imperative that you try your hardest to get this practice completed before you leave today so that I can have some completed work to grade when I come back. Have a great rest of your day, you guys.